the lack of energy. That. All right. That's good. So what did you guys think? Easy? Difficult? For the most part, easy? For the most part, you passed out because you couldn't do any of them? I mean, like, where are we on this graphing idea of sine and cosine curves? What do you think? Put at the top of your paper where you feel like you are right now on this graphing sine and cosine curve unit that we're working on. Where are you on a score of 1 to 10? Where are you on a 1 to 10? 1 means you have no clue what graphing even means. And 10 means I can sit down here today and watch you teach class. No one's ever going to put a 10 if I keep saying that. That's okay. Oops. Okay, I better put this on there for my kids and yes, my onliners. My onliners! Where is, oh, no, that's not it. Where's my folder go? Where's my folder? Documents. There it is. Woo! Boom. Whoa, there's no points. This is not for points. Come on, post it. Post-it note. It says it's saving, but it's not doing anything. It's assigning. It's not doing anything. There it is. All right. I'm going to come around and see what your scores are at right now. Where you're at on a 1 to 10. 15. Yes. Oh. I'm kidding. Okay. I'll give you 1 second. Okay. This is actually what we did on notes on the other day. Yeah, I'm sure. So there's that for you. And real quick, I'll give you that. Oh, there. Whoa! Using the old radicals on me. Okay. Right. Okay. And all right, so let's go through this. And this is all based upon understanding what the numbers in the function are doing to the sine or the cosine curve. So that first section there was no graphing involved. All you had to do was look at this and determine amplitude and period of each function. So real fast, just for review, amplitude is the absolute value of A. It's always a positive value, amplitude is. And then period is always 2 pi divided by B. So those are things you needed to know when we're going to do the first little section there. So here we go. On this one, the amplitude is 1. So I'm just going to say amp is 1. And on this one, the period is 2 pi over, there's the value B. We simplify it, and that is pi over 2. That's the period. What does that mean? That means it goes through a full cycle in pi over 2 radians. That's what that means. All right? Number 2, amplitude is 1, period is what? 2 pi over 5. Does that simplify? No, leave it alone. That's it, leave it. Number 3, amplitude is 2. Here the period is 2 pi over 1, so it's just 2 pi. Number 4, the amplitude is 4. Not negative 4, it's positive 4. It's distance. And then the period is 2 pi over 3. Can't simplify it, leave it. Do not turn it into a decimal. Leave it as a fraction like this. Number 5, here we go. Amplitude is 2. The period is 2 pi divided by 4, so it's pi over 2. And the last one over here, amplitude is 3. The period is 2 pi over 2, which is pi. Any questions on the first 6? Nope. Okay. The next section, you were given graphs. Start with, you to find the amplitude and the period of the graph. So that's what we're going to start off with here. Okay? So I'm just going to write them down as an A value and as a what? P value. Here we go. So the A value here is what? It's 3. Beautiful. Love it. Okay? The period. All right. Now look. What I'm going to do is I'm going to trace a sine or a cosine curve. A cycle. This is one cycle of which curve? Sine curve. Okay? It starts at 0, ends at pi. That means the period is what? Pi radians. Is that okay? Yes, I hope so. We're going to come back to the next part in the section. I'm just going to get the amplitude and period to start. Number 8. Okay, let's look at number 8 now. Amplitude this time is what? 4. So A is 4. Again, I'm going to trace a cycle. I'm going to trace that. That's one cycle of which curve? Cosine. So it starts at 0 and it ends at 2 pi, so the period is 2 pi. So all I'm doing is writing those things down to start. Number 9. The amplitude is 2. The period, okay, here's sine. There's a sine curve. So what is it? 4 pi. And the last one down here, the amplitude on this one is 5, and the period. Now, this one, you got to think a little bit different, okay? I don't know if I trace a sine curve always starts on the midline. If I try to do a sine curve, what's the problem with that? I don't know for sure what this is and what this is. I don't. I could guess, and I might be right, but I don't know for sure. So I have to use places where the x values are known. The angle measurements are known. Hey, why not go from here to here and graph what? One cycle of a cosine curve. There it is. Okay. It goes from negative pi to positive pi. So how far is that? 2 pi. That's the period. Okay. We're going to come back to the other parts in a second. I'm not going to do the writing the functions yet. Any questions on what we've done on 7 through 10? How we got any of those numbers? We're okay? Because the period is always positive. It's the distance on the x-axis. So how far is it from here to here? Pi radians. How far is it from here to here? Pi radians. So the total distance is 2 pi radians. Any other questions on this little section so far? Then it's graphing. All right. We'll come down here, we'll do the graphing. And I think I need to just raise this up a little bit. It looked like earlier it was down just an ooch. That's better probably. Okay. So number 11, if you recall, we used what I called the 5-point method. If it was sine, these were the 5 points I was using. If it was cosine, these were the 5 points I was using. No matter which one it is, I'm using maxes, mins, and where it crosses over the midline, right? That's the whole idea of this. I'm using those key values to get my graph. So when I did this, I went through and I always did what? Wrote down A, B, H, and K. And then, because each one of those has an effect on the graph. All right, so what's the value of A? 4. What's the value of B? 1. What's the value of H? 0. And the value of K is 0. Now let's remember what these do. That's the amplitude. That affects the maximum and the minimum. This is going to affect the period. It squishes it or stretches it horizontally. So this changes the period. This is a phase shift. It shifts the graph left or right, where the cycle starts. And this affects the midline, which means it also has an effect on the what? Maximum and minimum. Okay? These two together give you your maxes and the minimums. So using these, if the midline is right here, if that's my midline at y equals 0, that's this thing, my max then is going to be 4 above that and 4 below it. So my max is going to be a 4 and my minimum is going to be a -4. All right? So that's what these two are telling me. This one tells me my period. What's my period? Just 2 pi radians. 2 pi divided by 1 is 2 pi. This tells me where my graph is going to start a cycle at. It's going to start at 0. So it's going to start here. This is where it's going to start. Okay, so let's think about this then. It's a sine curve. So my graph has to look like this. I need to know in my head sine goes what? Midline, maximum, midline, minimum, midline. That's what I have to be able to visualize in my head. What I want to do is mark here where those are going to be at. Now this one's not bad. Why? It's going to start at 0 and it's going to end at what? Where's it going to end at? It's going to start at 0, and if it has a period of 2 pi, it's going to end at 0 plus 2 pi, which is 2 pi. So it's going to end down here at 2 pi. I already have the axes labeled for you on this one. Okay? So we should just be able to graph this. Starts in the midline. Okay? So my critical values are going to be here, here, and then what happens? You had to do what with this little section? Cut it in half. So then there was one here. Then you cut these in half. Right? That's where the critical values are going to be at, in those key locations. They're labeled for you already. All I have to do is put my values there. Boop, here we go. Midline. Then it goes to a what? And my maximum is at 4. Boop. Then it goes back to the midline. Then it goes to a minimum of -4. Then it goes back to the midline. So my graph looks like that. That's one cycle of an infinite number of cycles. It continues doing that over and over and over again. Any questions on number 11? Yes? No, that's fine. If you went ahead and did this part back here and had it go back and you had another one that looked like this, you just graph 2 cycles. Same thing. It's okay. If you can graph 1, you should be able to graph as many as I really would want. It just repeats the graph over and over and over again. Now, one thing I'm going to tell you is this. have done this using what? Had they used 1 and 2? Desmos, right? You could have just typed it into Desmos, looked at it, copied it, boom, bam, slam, no issues with that. You would have been able to do that, and you would have had a graph that looked perfect. Here's where that's going to be dangerous if you just do that every time right now. I'm showing you where we're heading today. So there's a reason I'm saying this to you. Okay? Because today, you're going to be doing, are you going to, no, you. Okay? We're going to be doing, that's not it. What in the world is going on? I don't even see it. Where'd it go? That one. I bet it's opening up over here. It is. Oh. So nice to have multiple screens. Okay. Here's what's going to happen today. Later on today, I'm going to give you a graph like this. I'm going to give you where it starts at, and let's say I gave you this. And I said, write a function for that. If you don't know how to graph it, good luck trying to write the function for the graph. You're not going to be able to do it. Because you're not going to understand how to find the values of A, B, H, and K. So the reason I'm making you do this by hand is so that you'll be able to go the opposite direction and get a function for a graph. That's what this is about. Okay? That's why I'm asking you to please, please. If you check it on Desmos, is that a problem? Heavens no, that's fine. That's smart. But if that's all you're doing, you're going to hurt yourself. Trust me. When it comes to this part of the lesson. Okay? So please, please, please do these by hand. Okay, boom. And you get out of here. All right. So now we'll go back where we were. There we go. Any questions on the front, this first side, on so far? 11, any questions on 11? All right, 12, here we go. We're going to approach it the exact same way. So I'm going to write A equals, B equals, H equals, K equals. I don't know why I put a 0 there. I think it's already a 0, but here we go. So A is 2. B is the coefficient of x, 1. H is what's being added to x, 0, or subtracted from it. And K is what's being added up, 0. All right, great. Here, what do I know now? I know that this is going to have a maximum of what? 2. And how do I find it? It's the amplitude plus this value. And this stands for the what? Midline. Remember, this is the midline. So the max is 2 above the midline, and it's 2 below the midline. So the max is 2, and the minimum is -2. Period, easy enough. The period is going to be 2 pi, and there is no phase shift, so that means it's going to start where? Start at 0, and it's going to end where? 2 pi. Now, if I know where it starts, and I know the period, how do I find the ending spot? If I know where it's going to start, and I know the period, how long it's going to last, how do I know where it ends? It's just, yeah, add them up. It's the what? Phase shift plus the period. That tells you where it's going to end at. Okay? Great. This already has them. Here's 0. Here's pi over 2. Right here. Here's pi over 2. Boom, boom, boom. So, again, I gave you a nice one here. It's going to use those critical values right there. Okay? So I'm not even going to put that there, so we're going to graph it. It's a cosine curve, though. Cosine doesn't go start on the midline. Cosine starts on a maximum. So I go through and I graph it. Okay, at 0, I'm on a max. And my max is 2, so I'm going to be right here. Then it goes through the midline at my next critical value. Remember, my critical values are here, here, cut those in half, cut those little pieces in half. Okay? So it goes here, here, then it goes to -2 a minimum, then it goes back to the midline, then it goes back to the maximum. So this graph looks like this. That's one cycle of it. That is one cycle of it. Right? What does each one of these distances here represent on my circle? The quadrants. This is going in quadrant 1, 2, 3, and 4. And then when we get back to quadrant 4, what happens in our circle? We start to repeat ourselves. That's why the graph repeats. All right. Questions yet? We're okay? All right. What's that? After we do the next two graphs. Didn't we have 2 or 3 more to do? Yeah. I want to do those first before we do. Make sure we've got those before we try to write a graph. And we're going to write those. We'll come back. Okay, here we go. This one. A equals 2, B equals 2, H equals 0, K equals 0. So what do I know right now? I know that Y equals 0 is my midline. That tells me my max and my min are 2 and -2. The B value is 2. That tells me that the period is 2 pi over 2, which is pi. And then this is where it's going to start. So right now, I know it's going to start at 0, and it's going to end at 0 plus the period pi, so it's going to end at pi. All right, so now I have to be a little careful here. So here we go. I'm going to just put arrows. It's going to start here at 0, and it's going to end here at pi. What do I have to do? Cut that in half. That's right here. What is this at? Pi over 2, right? Then I have to cut those in half. What is this right here going to be then? Pi over 4. And this is going to be at 3 pi over 4. So if they're not already labeled on the axis, you would have to include those. So you would really, if I was giving this to you as a quiz, I know that's 0, that's the origin. But right here on a quiz, I would expect that right here you would write pi over 4, and right here you would write 3 pi over 4. I already have the other ones for you. All right, let's graph this thing. Let's do this. Here we go. So it's a sine curve. Sine starts on the midline. And where's the midline at? The midline is at y equals 0. There's the midline. So I know I'm going to start on the midline. My next location, my next critical value here is going to be a what? Maximum. And it's going to be a max of what? 2. Then my next critical value is going to be a what? Midline. Then my next one's going to be a minimum. And my next one's going to be a midline. Whoop, done. There's one cycle. How many cycles could I get on this entire graph paper here? 4. Beautiful. I can put another one here, and I can put 2 over here as well if I wanted. All right. Okay. Questions on that one? All right, number 14 is a little different. All right, A is 1, B is 2, H is 0, K is 0. So what is this telling me? My midline's at y equals 0, my max is 1, my minimum is -1. The period for this is going to be what? Pi. So it's going to be using these exact same values I used over here. Same kind, because there's no phase shift. So I'm just going to go ahead. I know this is at 0, pi over 4, pi over 2, 3 pi over 4, and pi. It does, and we're going to talk about that now, okay? All right, so what this negative in the front is going to do, think of it like this. If I graphed cosine, let's just graph, I'm going to start by doing this. This is saying take a negative times the cosine of 2x. That's what this really is, okay? If I were to graph this, the cosine of 2x, let's just graph that. Here's my midline. Y equals 0. Okay. So if I was graphing this using this information, cosine starts at a what? Maximum. So it would be what? Here I'd be at positive 1. Then I'd be at the midline. Then I'd be at a minimum. Then I'd be at the midline. And then I'd be at a max. This would be that curve right there. If I took this now, this function, and multiplied it by a negative, that means I would take all the y values and multiply them by -1. What does that end up doing to the graph? Flipping it across the x-axis. So all of a sudden, what really would happen is this would not start at a maximum. It would start at a minimum. It would start here, midline, maximum, midline, minimum. So your curve would actually go like that. This right here is the curve that you want. That's the answer to it. So the negative, all it does is it flips it. So over here, if this is the sign, the cosine, if it was a negative sign, the midlines stay the same, but every max becomes a minimum. That's all it changes, guys, is the maxes and mins just flip. If it's a negative a value in front, it's a reflection. All right. This is the last one I asked you to do right here. Last one. Here we go. What's the a value? 3. What's the b value? 1. What's the h value? Careful. I say this every time. Careful. Thank you, Noah. It's -pi/4. Remember, it's the opposite. It's it's x minus h. So this is minus a -pi/4. Okay? Think of it this way. We want this to start at what? Usually, where does it start at? 0. What would I have to put in place of x to make this 0? What would I have to put in place of x to make this 0? -pi/4. Okay? Boom. There it is. And the k value is 0. All right. So my midline is right here. Okay? What's my max value going to be? 3. My min's going to be -3. Here we go. Where's it going to start? At -pi/4. All right, great. What's the period? 2 pi. Where is it going to end? It's going to end at -pi/4 plus 2 pi. Which is what? 3 pi/4. That's where it's going to end at. All right, so now I'm looking at my graph, my grid here. I'm looking at it. If that's -pi/2 and that's 0, that means this is what? -pi/4. This is 3 pi/4. Now I need to cut that into what? Half. Now there's a couple ways you could do this. One easy way of doing it is just counting in. 1, 2, 3. Boop. Where's that at? pi/2. Now count in again. Uh-oh. Boop. It's going to be right here. What in the world is going to be right there?
The 3 pi/4 is supposed to be 5 pi.
What's that?
Isn't it supposed to be over?
I don't know. Is it?
Yeah.
Is it at 5 pi/4?
Yeah.
Or is it at 7 pi/4? Oh, Mr. Snyder, you're trying to trick us again, you big goon. So this is 7 pi/4. Now wait. Why? Because this turns into what? 8 pi/4. 8 pi minus 1 pi is 7 pi/4. Oh, Mr. Snyder, you tricky man, you. So 7 pi/4 is what? Way down Here's 7 pi over 4. All right, let's cut them in half. Here we go. Boop, 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 boop. Here's the middle. What's there? What's halfway between pi over 2 and pi?
3 pi.
Thank you. Do it again. Boop, boop. Pi over 4. And then, of course, what's going to be right here? 5 pi over 4. Those are my critical values I'm going to be using on this graph. All right, let's do this. We're almost done with this one. Here we go. It's a cosine. Cosine starts on a maximum because this is a what? Regular a value. So it's going to start at a max. So right here, it's going to start at what? Positive 3. All right. Here, what's it going to do? Go through the midline. Here, what's it going to do? Negative 3. 1, 2, 3. Here, it's going to be back at the midline. And then here, it's going to be at positive 3. There's one cycle. All right. How are we doing? You guys are hanging in there. Okay, let's go back over here. And let's try to write a function for number 7. Now, number 7, notice I've already highlighted the sine curve I'm going to use for this. I've already got it traced. Okay? I know what a is. So I know it's going to start with what? 3. And it's going to be 3 of what? Sine. That's the way I'm going to write this one. So I literally have to know what is A, what is B, what is H, and what is K. All right, so let's think about this. I have A. Check. B. Uh-oh. Now let's think about this. Remember what we said. The period is equal to 2 pi over B. Correct? So what is B equal to? If I solved this little equation for the variable B, what is B equal to? I don't want to know that. I want to know this in general. This equation right here. What does B equal? 2? What happened? There's a pi symbol in here. That can't just disappear. Literal equation. Solve for B. Literal equation. It's like in physics class or chemistry or some class where they say, hey, here's a formula. I want you to solve for this variable. How do I solve this equation right here for B? Geiger, what's that? Not by 6. What is that? That's a... Oh, I thought you said 6. Yeah, multiply both sides by B. So now I've got P times B equals 2 pi. Oh, so what does B equal? 2 pi over P. Oh! That's not so bad. Because I know what the period is, don't I? My period is what? Pi. So this is equal. So I know that B is equal to what? 2 pi over pi, which is what? There's my B value. I got it. I found my B value now. All right. Is there any kind of phase shift? No, it's starting where? At 0. Is there a vertical shift? No, so that means K is 0. So it looks to me like this equation right here could be written as y equals 3 sine of 2x. Done. That's how you would do any of those. The same technique. Same technique in all of those. All right? So if you know the period, you can find b. b is always 2 pi divided by the period. All right? Okay. So we're going to be doing more of these today, trust me. And there's not a lot of room kind of here. It's kind of jammed up. So I'm not going to, if you want to try those and ask me, you can. Right now, I want to go away from those. And I want to check to see if you guys can do number 16. So I would like everybody right now to focus on doing number 16. Would you please graph number 16 if you can? If you have a question, please raise your hand, get help. Gladly help you. Okay? Everybody looks like they're here today. It's the same old code I've always used. So that's if you're doing this. It's fine. We'll take care of all that. So if you just take care of that, and if you can, you can. If you can't, I'm not going to get set up.
You know, if this guy you said the 2 bands, I don't know if that's Dave or just doing.
I tried to do what I did up here, what he did up here. Because it's negative.
Yeah, I understand, but I'm not sure.
I'm not sure.
That's like what?
necessary for you to know that.
Oh, yeah. She talks about it. You go shift and then quotation mark. And then hit your view. Yeah. Did it work? It worked for me. Shift quotation mark view. But that just makes sense. Right. I go do it. Quotation mark. What was it? A question mark? What? Whatever that. I don't know.
How's it going, everybody?
Good. Good.
Happy Thursday. Grabbing a little sine curve today.
Yeah.
A little horizontal shift up there. Negative 5.
Let's do this one. Here we go. Woo! The first thing I notice in this is it's going to be an inverted sine function. So I know it's not going to look like this. It's going to go here, down, up, like it's going to go upside down. It's flipped. I know that immediately by looking at it. So we're going to write down our stuff. So we know A is 2. That is the amplitude. B on this one is 2. H on this is negative pi, and K on this is 0. So I know my midline is at y equals 0. I know my max is going to be a 2. I know my minimum is going to be a negative 2. I know my period is going to be 2 pi over 2, which is pi. And I know I'm going to start at negative pi, which means I'm going to end at negative pi plus pi, which is 0. All right, so I know I'm going to start here and I'm going to end here. Well, this is nice because it's actually divided into the exact same number of pieces that I need. And that's already at negative pi over 2. This is negative pi over 4. This is negative 3 pi over 4. These are already given to me. Okay? So if I want, I can draw my midline. There it is. Let's graph this. All right. It's an inverted sign. So it's going to start on the midline still. So it's going to start here, but it's not going to increase. It's going to decrease. So it's going to go down to a minimum at negative 2. Then it's going to go back up to the midline. Then it's going to go to a maximum and then back to the midline. So this graph is going to look like that. Yeah.
So would the 2 not distribute to like the pi?
It doesn't. If you do that, if you look back at the notes I gave you this. A times sine of, and it looks like this. You have to have it like this in order to get the right phase shift.
So that always stays the same.
So if and you're going to see, actually we're going to do a problem like that in a second. So yeah, this is the form you want this inside in because this is the actual phase shift. Now, I'm saying that to you and you're maybe saying, what do you mean? Well, let's just go back here and I'm going to go down and look at this one right now. Look how the inside is written. It's not written the way I have it in the notes. That means negative pi over 2 is not the phase shift. This pi over 2 is not the phase shift. You would have to factor out the 2 to start. So if I was doing this one right here, I would rewrite it like this. Y equals, I don't like the 1 in front either. Where would I put that at? What is this 1 here? It's the k value. Put it at the end, plus 1. So I'm going to write 3 sine of, and then in here we go, 2 times x minus something, whoop, going to go in there, whoop, and then at the end, plus 1. My question is that what's going to go right here? If I factor a 2 out of this, what ends up right there is the question. What is pi over 2 divided by 2, in other words? Pi over 4. So you got to have it like that to get the right phase shift. Okay? Does everybody understand that? So if you see it written like this, you must automatically say, well, that's not the form I want. I need to factor this value out, this b value out to start. Bless you, by the way. And that way I'll get the right phase shift. Okay, it'll give me the right phase shift. Okay. All right, so let's, on number 17, would everybody please write down what it's got, what I want? Amplitude, period, horizontal shift or phase shift, right? Midline, where is it? And then where do you start and stop your cycle? So I'm asking you to write down all of the basically what? A, B, H, K, all that stuff I'm doing before I graph it, that's what you're doing right here on number 17. While you're doing that, I'm going to pass out paper here. I'm going to open this window up some more because it's gross in here. How was that trip, Ryan? Was it good? Nothing bad happening while you were there? No. Good. You're expecting rain today? Yeah, it's gonna rain. Yeah.
So the amplitude A is different.
Amplitude, well, A is this value.
Yeah.
amplitude is the absolute value of it. Because amplitude by definition is a distance. And distance is always a positive in that when we talk about it. So the negative in front of it, so amplitude is the distance between the midline to the maximum, right? So if there's a negative in front of it, all that's telling you is it's going to flip over. Okay, so the amplitude is always the absolute value of A.
So it's like what's so I get the point. So the amplitude of this right here out.
This is the amplitude right here.
Okay, so then the minimum would that be?
So okay, so here, what's the midline at?
2.
So the max would be the midline plus the amplitude. And the minimum would be midline minus the amplitude.
So what? So the amplitude is different between the max and min are separate, I guess.
Yeah, a lot of times they look the same. If the midline's at 0, then the max and min look like they're the what? Amplitude value. But if the midline shifts, then they're going to change the max and mins. Okay? Okay, let's see what we got on this guy. So, my amplitude on this is what? My amplitude is 3. The period, P, is 2 pi over 4, which is pi over 2. So I got that. The horizontal or phase shift is what? Yeah, negative pi over 2. So I'm going to make that my H value, negative pi over 2. Okay? And then the midline, which is K, means that the midline is at y equals positive 2. So that's amplitude, period. Phase shift is this, is the H value. That tells you the phase shift. And then the midline is the same as this K value right here. Then it says the start and stop of a cycle. Now, I didn't ask you to write down the max and min. We should be able to know what those are, though. So I'm just going to do it here as a question. What would the maximum be on number 17? 5. And how did I do it? It's the what? Midline plus the amplitude. So the max of this thing would be at 5, and the minimum this graph would ever go to would be at what? Negative 1, right? Because it'd be 2 minus 3, so it'd be at negative 1. Okay? So I have start and stop. Now I actually almost have the start, don't I? The start is the same as the what? It's the phase shift, the horizontal shift, the H value. So I know this is going to start at negative pi over 2. It's going to end at negative pi over 2 plus pi over 2. So where's it going to end at? 0. How do we feel about that? Are we okay with all those? Sam, you okay with those? No questions? Anybody have any questions on anything I just did on that particular problem? Right? You got them all? You good with that? Okay. Here's what we're going to try. So we're going to I never had planned to do the rest of these. We're not going to do the rest of these right now. What I want you to do is I've just given you a sheet of paper. The sheet of paper I have given you is the kind of graph paper that I will provide for you when you're graphing for me. Okay? I've created this one because I like it, and I've got nice spots on there. So I want everyone to look at that while I am calling up this exact same stuff. Let me pull this over. Okay. So if you look at this, this is what yours looks like. Okay? Notice what I've done. When I created this for you, this, of course, is at 0. Okay? What do you think these 3 spots right here are?
Pi over 6, pi over 4, and pi over 2.
They are pi over 6, pi over 4, and pi over 3. That's what they are. And then this is pi over 2. Now, I want everyone to stick with me. That means that if this is at pi over 6, what would this square right here be? Pi over 12. This is broken into pi over 12 increments on the horizontal. This horizontal, each square on the horizontal is pi over 12. 1 pi over 12, 2 pi over 12 is this, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12 is pi over 2. I have made it so it's broken down nice and neat for you. Okay? That means this would be all the negatives, right? So now I don't have them labeled for you. I don't have them labeled for you. So if you were graphing, you must write down what those spots are. So I know you know what they are. I've made it as nice as I could without actually putting the values there and cluttering it somewhat. Okay? Now, when it comes to the vertical axis, does the vertical have to be the same as the horizontal? Well, it can't be. This is in radians. Is this in radians? No. So I can make the vertical whatever I choose. Now, if I'm graphing a sine curve and the amplitude is 1, do you really think I want to make one block 1? Probably not. Which means you need to be good at labeling those values, especially where the maximums and the minimums are. And if you have a midline that's not on the axis, you want to label where that is as well. So I'm giving you kind of a structure here to work within, but you have to do some things on your own when it comes to labeling the graph, right? What we're going to do right now is we're going to practice graphing 4 more difficult ones, where you have multiple things going on. Okay? Where you have multiple things going on. So, what I want you to do is you've got a total of 6 graphs here, okay? What I'd like you to do is, you're not going to graph them. I want you to write these 4 down so I don't have to keep coming back to this page. So you can write these down if you want, like on the top, you can put down this equation, and then maybe the next one you're going to write this equation here, and then on the back you're going to write this. That way I don't have to keep coming back to this page, all right? So if you would do that real quick, and then we're going to graph the first one as an example again, and then I'm going to ask you to try maybe the next one, and so on and so on. Or maybe I'll have you do the first one on your own. Okay? And I was nice on these. I did not give you any inverted functions. Nothing on this is inverted. How do I know that? I don't have a negative in front of anything. No negative A's. This building feels very warm today. Oh, that falling Monday. Not this one. Okay, the falling. So that's not this coming Monday. No. That'd be the following Monday. Because if you're going to be on Thursday and Friday, then the following Monday after surgery, you keep on like that. Yeah, I know. Right. Okay. Okay. Well, like I said, everything will work out. We'll take care of everything. The good thing is, like if on a Wednesday if we need to, we could probably get together and talk or whatever, so it's not a big deal.
But don't we also not have school?
We don't have school on that Tuesday, correct? And then the Wednesday, we have testing going on here, air testing, but I still would have the afternoon if you need to, we could talk. And maybe even the Tuesday, I might be able to have you come in the afternoon and do testing. So, okay, so I'm going to real quick. Copy that. Here. Oh, there you go. I want the other one. It's copied. Really? Copy. And the last one. All right, so let's go ahead. I bet most of you actually could graph the first one. I think you guys should just try the first one on your own. I really think the first, I mean, and if you've noticed, I went from kind of an easier one to a more difficult, to a more difficult, to a harder one at the end. So they're gradually getting harder as you go through these. So I think actually we'll just do it where you graph it, I'll graph it. You graph it, I'll graph it. You graph it, I'll graph it, and then we'll see how we're doing with it. And then we can take questions. Let's do this one. Here we go. So this particular problem, okay? So things that I know. All right. I know that this has an A value of 3, has a B value of 1, has an H value of what? 0, and the K value is -2. How do I know that that's not the H value? It's not in parentheses. It's not in parentheses, and I can't say it's being subtracted just from theta. It's being subtracted from 3 sine theta. All right, so I'm going to start right now on this, and I know now I have to take care of my max and min as well. So my maximum on this is going to be -2 plus 3, which is 1, and my minimum is going to be at -2 minus 3, which is, okay, so I need to go from negative or from positive 1 to negative 5. So that's going to make me think about my y-axis, how I want to label it. So you tell me what you want to do. I don't want to go by ones. I can tell you that right now. Okay? I would not want to go by ones. We'll go by twos. Okay, we could go by twos. So if I go by twos, I'm going to label this as 1, and then I'm going to label this would be negative 1, negative 2, negative 3, negative 4, negative 5. Okay? I also should probably label negative 2. Why? Because that's where my midline is going to be drawn at. If the midline is shift, I need to show that. Okay, so the midline is right here. Okay. So my graph, keep going with this. If that is 0 and this is 1, I know it's going to go from what? 0 to 2 pi. The period of this thing is going to be what? 2 pi. 2 pi over 1 is 2 pi. Great. So here we go. Here's 0. Okay. These ones that are kind of by themselves, those are the axes. That's pi over 2, pi, 3 pi over 2. This is 2 pi. And then that means I'm going to cut it in half. What's that mean? Oh, it means I'm going to be here at pi, pi over 2, and 3 pi over 2. That's where my values are going to be at, my criticals. My maxes, my mins, and my midline intersections, okay? All right, so let's go ahead and graph this. It's a sine, a regular sine, which means it's going to start on the midline. So it's going to start right here. Then it's going to go to a maximum. So it means at pi over 2, I'm going to go up to 1. Then at pi, I'm going to go back to the midline. At 3 pi over 2, I'm going to go to what? Minimum, right? So over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then at 2 pi, I'm going to be back to the what? Midline. This is my graph. Notice that this distance, it's a little off there, this distance and this distance would be the same. This distance and this distance are the same. And that's the what? Value of A. Okay, that would be the value of A. Are we okay with that one? Anybody have any questions on that one? Then please try the next one. Got it, Krista? What? Not yet? Okay, that's fine. You got like that important stuff written down? Yep. Good. Good. Is that it? No, it's the opposite. Because remember, what you're looking, the shift is what would you put in your formula to make that equal to 0 inside? Which is the opposite. Okay, that's what you have to think about. Okay, yeah, so this is going to be what? Booyah. Yeah, you are. You got it? Okay. Yeah. How do I do that now? Okay. So if you know where you're going to start, if I said I'm going to start here, and I told you that these are 12-inch squares, okay? Or let's just say they're a foot. Okay. I start here. Let's say I'm starting at 0. And I told you I'm going to walk 12 feet. Would you know where I'm going to end up down there? Yeah, it would be what? I'd be at 12, right? This is 0. I'd be at 12. So if I was starting at -2 and I was going to walk 12, where would I end up at? What'd you do to those two numbers? You added them, right? -2 plus 12 is 10. If you know where you're going to start and you know how far you're going to go, all you have to do is add them to find the distance. That's it. That's it. So on this one up here, where are you starting at? Yeah. Okay. And what's the period of this one? So these two, what's the period? Perfect. So you're going to then, let's say you start pi over 2. You're going to end at pi over 2 plus pi. That tells me where I'm going to end at then.
So it's h plus b.
Yes. Yes, yes, yes. Yep. I think I may have written it down in the past and you just weren't here for it. Okay. All right. Let's go ahead and take what we got here. So I'm going to go ahead and just ask. So on this one, the amplitude is what? 1. So I'm just going to say the amplitude is 1. What's the midline on this one? The midline is y equals 0, right? So that means my max and my min are just going to be 1 and -1. I'm just, boom, writing those down, okay? So the other things I need are the period and the phase shift. So here we go. The period of this is 2 pi divided by what? B, which is what? 2. So the period is pi. So it's going to go through a full cycle in pi radians. I have to know where it starts at. Oh, that's this. This is where it starts. Now, guys, you have to remember it's the opposite. Again, what would I put in here to make this equal 0? Pi over 2. That's why you have to use the opposite. The cycle on a normal sine and cosine, the cycle starts at 0. You have to say to yourself, what would I have to put in here to make this 0? It's always going to be the opposite of what you see over here. So this means it's going to start at pi over 2. And it's going to end at pi over 2 plus the period. Which means you're going to end at what? 3 pi over 2. Those are my things I need. All right? So pi over 2 is here. 3 pi over 2 is here. So I know that to start. I'm going to make this a little smaller now. All right. So now, of course, I have to do what? Divide those in half, right? Well, that was nice. What's halfway between pi over 2 and 3 pi over 2? Pi. And then what's halfway between these? This is going to be what? 3 pi over 4. This is going to be what? 5 pi over 4. Okay. And that's easier to think of the unit circle than it is on the graph. That's why the unit circle is coming into play when we're graphing here. We're thinking of it. All right, here we go. Let's graph this thing. Midline. So on this one, I'm going to let what? You tell me what you want to do for the vertical. How many squares do you want to be 1? I heard, did you say 5?
Yeah.
5. It doesn't matter as long as I'm looking at the graph and I know that's all that matters to Jeffrey. That's me, by the way. So 1, 2, 3, 4, 5. Boop. That's 1. 1, 2, 3, 4, 5. Boop. That's -1. So my midline, of course, is right here. Y equals 0. Let's graph it. Okay, it's a cosine, non-inverted. We're just going to start at a maximum. So here it's going to start at 1. Then it's going to go through the what? Midline. Then it's going to go to a minimum, 1, 2, 3, 4, 5. Then it's going to go back up to the midline, and then it's going to go up to a maximum, 1, 2, 3, 4, 5. Boop, done. That's it. Is it getting easier? Yes? Okay, so let's just do it this way. We won't be able to do and go over those last 2. Just do them. We'll start class tomorrow with those. Tomorrow, then, we're going to start writing them for graphs. Tomorrow, we will start giving you a graph and asking you to find A, B, H, K, and write the function. Yeah. Yes, correct. Yes, correct. Yeah. So whenever you're doing this, Whoa. You go down there a lot.
I do too. I know it's saying in the cabin, I think. Why did it say when it's staying in the hotel? And I'm staying in the cabin. Wait, where is that exactly?
You guys usually stay in the cabin?
Must be.
We used to camp. In rock and smoking out.
Yeah, my aunt, she has her own cabin. She usually stay in that.
Does she live there year round?
No,
So she just said that it's a easy place?
and then she has like her own cabin type of house and go here in the car.
Wow, how nice. I love cabins. There's something so peaceful out sitting in the cabin.
They got a jet ski accident, so they haven't had people out there. They've been scared about people not being responsible.
All right. Have a great one, everybody. Yes. How's it going on this, Mr. Wright? You getting this? Brady, you good with the two?
Yeah.
Fantastic. Fantastic.
Andrew, what did you get on the multiple choice chemistry?
humid and gross in here.
Yeah. You have a window open earlier, or
No.
we just keep it in there?
This end of the hallway is not good.
Oh.
We really like the name Lainey now. But Lainey is so, like, little girlish.
Yeah.
So, and there's this girl that is friends with a friend or whatever that name is just Lainey.
Yeah. That's my niece's middle name.
I don't know. Norbert Bakers. Maybe he's just having kids sing it.
So, we like that name. But then the other day, Jonathan was like, even if we have a boy, we could name a boy that.
Lane?
Because there's Lane Coulter, who plays baseball for
Oh, yeah,
him,
Blaine.
who is also just like an incredible kid.
Yeah.
Like,
There's Lane Bryant,
Lane Brown.
Dorothy Lane.
So,
We talked about how Melanie, you could shorten her name to Lane or Laney.
yeah, Lainey. I love Lainey. My friend at the pool's daughter is named Lainey, but it's like we only spend the summer together. Like we don't.
Yeah.
They're gonna go to Alter. And they're gonna be.
Your kids are going to Alter?
What?
Your kid's gonna go to Alter? Wow.
Jenny.
I just heard her say it.
No.
Yep.
These girls' kids are going to Alter.
Graduation is actually happening. Wow. Well, yeah, I'm going to this meeting.
Did we get an email for it?
I don't know if everybody did or I did because we worked.
Oh yeah, you probably just did.
We're going over to UD next week to check it out, see what we're being told is going to happen.
Next
You
Wednesday.
have to go to UD, or they're asking you if you
No,
want.
we want to know because everybody has to use the exact same setup. So we have to go in and know what are we going to have to try to do? How are we going to
Is
make
Kate
our
here?
graduation work in
Yeah.
this setup?
Lunch duty. She is here.
So that's going to be
I
different.
haven't seen her at all. Water bottle.
Water bottle. Oh, Wetzel.
I stay hydrated.
Yeah, especially for pre-calc. Oh. Tomorrow, I'm going to give them graphs and make them write the functions. Had a kid today, last night's homework, all he did was use Desmos to graph. I said, hey, you got them all right. I said, good luck going the opposite direction. If you don't know what those values mean, you're not going to go the other direction.
It is really nice that Desmos converts X values to in terms of pi.
Yeah, it does.
That's amazing.
It really is.
They didn't do that a few years ago.
No, I don't know when that changed. But in the past, I haven't used Desmos much. I've used the TI mostly for it.
Yeah.
So
Is
I
the
wouldn't.
ACT, do they have Desmos yet or no?
No,
just
it's
still
kind of like,
calculator?
isn't it?
ACT did.
But it wasn't. Was it a pop-up though? You could
I don't know
only use
exactly
Desmos
what-
if you did it online. If you were doing a paper copy,
Right.
you had to use
Right.
a graphing calculator, a TI.
Right.
If you're doing the online ACT, it's kind of embedded as part of the test.
But it's full function.
Right. But it's yeah. So
You might be able to make it full screen. I don't know.
right.
Well, it's not full function, meaning like it won't solve an equation.
Won't solve an equation. Like
Yeah, I think it's like the same test mode that is
Yeah,
like a rare one.
Yeah.
But it's pretty much, like, there's a few things it won't do.
it will do like decimals to fractions and fractions to decimals.
Yeah.
It will do that in the ACT version.
Oh, yeah.
Did you accept your invitation to the UB Marina thing next Wednesday to go check it out?
Oh, I haven't seen it.
We just got it before you came over.
On Wednesday?
Yeah, like 11:30 in the morning.
Seen it by lunch.
I doubt it. I'm still going. If I can get out of the compound, I'm going. That's my chance to escape.
Anyone heard any contract ones?
Oh, yeah, that meeting is
Next Wednesday
next Wednesday.
in Trent.
Rebecca said she expects people to use please, but not doing the cartwheels. That's what I let her.
I'm
It's better than
surprised she said
this.
that. She's normally pretty tight-lipped.
She's my roomie. She's kind of.
Giving in.
I want a 3-year deal.
With a buyout option,
3%, 3%, 3%.
with a buyout at the end. 3rd-year buyout option, if you don't want
Those
to.
were the days.
I know.
3-year deals, 3%, 3%, 3%. Those actually happen.
I know.
So earlier in your career, you get 3% on the base, plus your step, plus your lateral move, if you move laterally.
You have some huge jumps.
In 3 years, I could have my salary go up $20,000.
You can do that if you became an administrator.
Yeah, you could be the HR person.
Doesn't have
That
to
is
be
new,
insurance.
creative, yeah, brand new administrator.
I saw that. I'm like, great.
Let's apply.
But then is the other position up on there or is that Debbie?
Yeah,
Yeah.
But they didn't even try to administer. Like,
I know, I wonder what.
I thought that one was, I thought I checked.
I thought it was too, but it's not?
it's like kind of like a master.
I
But
thought
it
the bottom
doesn't-
it said administrative pay
It's
scale.
administrative pay scale, yeah.
I think that's what it said at the bottom.
I don't know. I'll have to go back.
Here, yeah.
Supervisor of
I do think it's weird that it's called a
of
supervisor.
early childhood. At the bottom it says according to approved administrative salary.
That might
schedule.
be why they can get away with hiring some of this stuff.
Well, that'd be good for you.
Yeah. No. I don't think that's one word. Too much drama with those pictures.
Being an administrator is, has no appeal.
I feel like so my head to the fucking.
Half thought about the JFK one.
What?
I said I half thought about the JFK one. It's like a perfect.
I wonder if Tyler's gonna go after that in Georgia.
Oh.
I did
If
wonder
he was, I'm sure it was great.
if some dominoes are gonna start to fall.
Yep.
All things is one.
Oh my
One
gosh,
big
I
domino.
didn't even think about that.
I did. I didn't say it.
Absolutely will go after that job, right?
Well, it also puts him in a job that he and Sherry are not in conflict with one another.
Go.
The first domino might fall.
Or the other dominoes.
Well, that means
Jenny?
that principal is open. Which means the unit principal is gonna be open.
Then you can
Which
Nicole.
means counselor might be open. Which means math department chair might be
I was
open.
gonna say, means that everyone's special, might be open.
Gives me anxiety.
What? What is angina? Or,
Just,
yeah. I didn't know that. What is that word? Why would they ever make that word? I've heard it before.
I've never heard it.
Really?
Never. But why would that be what
go
it's
ask
called?
Dr. Phil.
What angina is? Oh my goodness.
Sounds like someone's grandma. They got picked on in school a lot.
Like angi, like that's angiogram.
Yeah.
Is that chest?
Yeah. Isn't probably worse.
Oh, wait, the problem. What other word has that in?
Well, anterior is like front, posterior and anterior. So
So it'd be like the front of your body, the chest would be. So and the prefix.
Can you imagine? Oh.
So go from one sheet. I know.
And just
Roll it right in.
I'm so hard to get jacked up against the wall.
You get the head, it does happen.
Andrew was talking to Andrew and Tim, and after doing lunch dating in Michigan, he's already working. Yeah, why is she doing lunch dating? I was working on that.
Who?
Andy,
Oh.
they're eating her lunch.
So,
Yeah, she went up there. She had a meeting at Tim and Betty for like all this.
What for?
Maybe she's gonna go for the new friend.
I think she just went. Okay. I'm sure she'll go for that. It is. Yeah. What is that? Yeah.
Does she have elementary experience?
Yeah. Working here. But I don't know, like, what I don't understand is when you apply for your principal's license, it says you have to have an elementary or middle school principal license. Yeah, so I wonder what her principal is. Like, I don't know how I.
She has a
would-
superintendent's license that trumps it.
Yeah, I get everything.
Oh, no, yeah, I don't know if she's not, it's.
Yeah, because you can get your principal license in elementary with elementary experience, yeah. What would you ever pick? I know, I don't know.
Superintendent's license is like the license trump card.
No, you still.
I mean, you can, if you have a superintendent's license, you can walk in and teach a math class.